Hi, my name is Fabian Seiler, and today I want to talk about the paper Accelerated Image Processing through Imply-Based NoCarry Approximated Adders, which was accepted at the Transaction on Circuits and Systems 1. In this work, we wanted to combine two emerging computing paradigms, namely Approximate Computing and in-memory computing. For this, we wanted to utilize the stateful logic imply, in which two operations are valid, implication and false operations. So if we have a standard Boolean equation, we first have to convert it to imply logic, which is done in a truth table like this. So this truth table you see on the bottom left here represents imply operations. Afterwards, we also wanted to do efficient topology mapping, because as you can see, there are very different topologies available for imply logic, and most of them were not really covered in the state of the art. So we want to do a little design space exploration and look at what approximated adders can be actually implemented on different topologies and what are the differences. So they also have different constraints, such as the available number of computational areas, the number of memristors, and the connectivity, as you can see here with the switches. We also have to consider that we want to gain have gains on application level, such as a reduced energy consumption or reduced latency. So how we're actually implementing this? We disregard the carry propagation, so that's the approximation for this work, and is inspired by the lower adders. We do a functional representation, so for example, as you can see here, these two blocks are combined in two different logical equation pairs. Then we want to do an error evaluation, where we actually check if the accuracy of the approximations are fine and lead to valid results on, for example, image processing applications. Afterwards, we want to find efficient imply functions that actually have the same truth table, but are only computed using implication and false operations. Now we come to the actual mapping part. So, as you can see before, the four different topologies have very different circuits behind them. And let's have a look at the example of the NoCarry plus adder we implemented. We now want to map these imply algorithms to different topologies. That means we have different number of computational areas and work memristors available. And this leads to very different implementations. So the algorithms is kind of the same, so the logical equations is the same, but the algorithm results on the different topologies drastically vary. As you can see, for example, here, the semi-serial topology, the semi-parallel topology, and the parallel topology, which actually just runs n serial algorithms in parallel, where it is possible, result in very different actual implementations of the same algorithm. And we have the different topology advantages available to us. The first is the parallelization, in which the parallel and the semi-serial and semi-parallel topologies really shine, and the work memristor usage, where we actually present a very nice work memristor switching scheme in the semi-serial topology. And what are the actual results of our work now? If we compare to the exact adders, as you can see here at the dark gray dots, we have drastic improvements. We are 6 to 54% faster with an approximation degree of 5 out of 8 adders. And we also require up to 54% less energy compared to the exact algorithms. We also were able to reduce the number of memristors in the parallel topology that are required. And we also have to use up to 63% fewer switches, also in the parallel topology. If we compare now to other approximated adders at an approximation degree at 5 out of 8, then we are 17 to 30% faster and 17 to 33% less energy is required for our approach. We are also able to improve error metrics such as the normalized and medium relative error distance. As you can see here, for example, at an approximation degree of 5 out of 8, we're up to 56% and 64% more accurate. So let's now have a look at the image processing gains that we were able to achieve. At first, we evaluated 4 different image processing applications which you can see more of in the paper. For now, we evaluated an example for the grayscale filter, where you can see the exact image here and the approximated image with 5 out of 8 edges approximated for both of our approaches besides it. As you can see, there's almost no difference for the human eye. And for this, we were able to gain drastic gains in terms of energy efficiency. We were able to save up to 26 millijoules of energy with an approximation degree of 5 out of 8. The same is true for the number of steps that are required. We were able to save up to 119 million steps for this one image only. That was all. Thank you very much for watching and have a nice day.